Hello, Mindsetters, and welcome to today's math show. I know the prelims are almost over, but finals are coming soon. So today we have a special revision lesson on trigonometry and analytical geometry. We have selected highlights from lessons shown early in the term to help you revise. You can download the notes for today's show from learnextra.co.za/live. Now it's time to get on with today's lesson. Please post your comments and questions on our Facebook page, facebook.com/learnextra, and on Twitter @learnextra, so we can help you with your revision.
All right, let's have a look at what we've got over here. We've got a piece of land that has been formed from a quadrilateral ABCD, and we have been told the following. The length from A to B is 20 meters. The length from B to C is 12 meters. From C to D is 7. And A to D is 28. Right, and what I know is that my angle is 110 degrees. So, the first thing that they're wanting me to find over here is the length of AC. That's this length over here. And they want us to work out what is the length of that AC over there. Right, so what do we have to do? I want you to very carefully look at your diagram and ask yourself, do I have a pair of an angle, a known angle, and its opposite side that I know the length of? If you've got that known pair, you know that you're going to be able to use your sine rule. Okay, so have a look at it, guys. I know that I've got an angle of 110, but at this point, I don't know what the length of AC is. So there's no pair over there. I know that this length is 12, but I don't know what angle A is, so therefore once again there is no pair. And I know what BA is, but I don't know what its opposite angle of C is, so there's no pair. Right, so therefore the sine rule is not going to be applicable here. We are going to need to use your cos rule, all right? And the cos rule is going to then be applied as follows. To find the length of line AC, I'm going to say AC squared is equal to, remember you had to take the two sides and the included angle. So I'm going to take the length of BC squared plus the length of BA squared minus 2 multiplied by BC times by BA times by cos of the included angle, which in this case is angle B. Okay. So now we're going to substitute it in. So the length of AC squared is equal to, BC was 12 squared, BA is 20 squared, minus 2, whoops. Let's just go up here, 12 times by 20 times by cos of 110 degrees. And the good news here is that you can actually type this into your calculator as you see it. So therefore, let's grab our calculators out and let's type in what we've got over here. Right, we had a 12 squared plus 20 squared minus 2 multiplied by 12 times by 20 multiplied by cos of 110 degrees. And that is equal to 708 let's round it off to 0.2. Remember, it's not AC yet, that represents AC squared. So remember, you must square root your answer. So I'm going to square root the answer that was in your calculator, and we are getting 26.6 as the answer for AC. Okay, so 26.6 is my answer there. And it's meters. Okay, right, so we identified that the fact that there were no pairs there, no pair of a known angle and a side, told me, it guided you that that was where you had to go and use your cos rule. Okay, next one. Now that we know that that's 26.6, so let's just fill it in here to help us out. All right, now they want to know the length, the size of our BAC. So my size from B to A to C, we're looking for our angle over here. All right, to the nearest degree. All right, once again, guys, go back and see. Have I now, by actually having found the distance from A to C, do I now maybe have a pair of an angle and a side? Okay, and in fact, yes, you do. I've got an angle, which I know is 110, And I now know its opposite side, which is 26.6. So now we're going to be able to use the sine rule. Okay? I've got that side over there, and we are going to apply it. I think we probably have time for an ad break, am I right?
Yes, you're right, Emily.
Okay, so what I'm going to suggest, guys, is quickly get the answer to that one, and I'm sure we'll be back in a 2 minutes. Okay, very quickly, I'm sure you guys all did that during your during the ad break. And the angle A was 25.1 degrees. Okay, so just have a quick look at it. I'd use the sine rule, and yours should look fairly similar to mine at this point. Okay, right. Then on the same question, they're not done with us yet with this question. They now want us to calculate the size of angle D. Okay, so there's angle D, correct to the nearest degree. Okay, so having said that, go back to looking for your pair. Okay, so we obviously, if we're looking for angle D, I think it's fair to say we now have moved into this triangle over here. And what have I got? I've got a side, but I don't have the angle opposite the side of D, so there's no pair. I've got C, which is an angle. I don't have the angle, but I do have its side. I've got A, which I don't know the angle, but I do have its opposite side. So I'm sitting with no pairs. So once again, the sine rule, unfortunately, we can't use. So what are we going to then fall back on? Your cos rule, okay? And the cos rule, as I mentioned earlier, you can find the size of a missing angle with 3 sides of the triangle. You just need to apply your cos rule, okay? So this is how you're going to go about doing it, okay? Take the cos rule as you know it. All right, which would mean this. If I've got that as angle D, I'm going to call that side little d. I'm going to call this side over here little a, and that little c. All right? So therefore, the cos rule would typically look like this. To find, if I knew angle D, I would actually start with the side opposite that. So I would start with little d, and I would say little d squared is equal to the 2 other sides, which is a squared plus c squared minus 2 AC cos D. Okay? But the part of the equation that we don't know is in fact that. Okay? So what I would need to do is I just need to rearrange the equation so that I can actually get cos D on its own and everything else off on the other side, because that's what I need to solve for. So let's see if we can do that. In order to get cos D on its own, all right, I need to move my a squared over the equal sign, and I need to move my c squared over. So the first thing we're going to say is that d squared minus a squared minus c squared would be equal to a negative 2 ac cos d. Okay? All right, so cos d is not completely on its own just yet. Now what we're still sitting with is negative 2ac. And the negative 2ac, remember, is joined to your cos d by multiplication. All right? So please don't make the mistake of thinking you need to add ac onto the other side, because it's not. This is all one term, all right? So you can't separate it with addition. You need to get rid of it by doing the opposite of times, which is divide, okay? So therefore, we're going to have this. I'm going to say d squared minus a squared minus c squared all over negative 2ac is going to leave you then with cos d on its own. Okay, so all I've done, grade 12s, is I've just rearranged the normal cos rule formula, okay? And now that we've done that, let's substitute in what we've got. Let's quickly just write it over here so we don't have to keep moving it. A was 7. C is 28, and D was 26.6. Okay, so let's sub that in. Okay, so we've got D, which is 26.6 squared, minus A, which is 7 squared, minus C, which is 28 squared, all over your length of negative 2a, which was 7, and c, which is 28, and we're still trying to find cos d. Okay, right guys, calculators out, and now we need to substitute in. Okay, so we've got our fraction of 26.6 squared minus 7 squared minus 28 squared. And that is over negative 2, 7 times by 28. And that has left us with 8 over 25. But okay, so let's just quickly write that down. 8 over 25 is what we have as a ratio. 8 over 25. That's equal to cos d. Okay, I'm not interested in cos d. I just want to know what d is. Remember, that's what we're trying to find, is the size of the angle. So therefore, we need to move cos away from it. And the way we're going to do that is say shift cos of the answer, and we've got 71.3. Okay, and there we go. That's the solution that we're looking for. 71.3 degrees, which is the size of angle D. Let's just make sure that it is an acute angle. Remember, we don't want to make any silly mistakes with that. I'm happy with that. 71.3 is going to be fine in terms of angle D. Okay, so there we go. That's one of your, definitely something to watch out for when applying your area and your cos rule, is that, yeah, if you're trying to find the angle with 3 known sides, that's how you're going to do it using your cos rule. Okay. Okay, let's have a look at this question over here. We have got a tower. Okay, we've got a tower, which is 25 meters in height, and they've given that the values of TB, and 2 cars K and L are on the road. The angle of depression, okay, remember guys, just regarding angles of elevation and depression, they're always from a horizontal viewpoint. So your angle of depression has got to come from that horizontal line down to the points on your diagram. And an angle of elevation will go from a horizontal viewpoint looking up. Okay. So the angle of depression from T to car L is 10 degrees, and the angle of elevation is 17 degrees. So let's see what they want us to look at over here. Now, bearing in mind, because this line over here and this line over here are horizontal, obviously they're going to be parallel. Okay, so the very first question is actually asking me to find the size of angle L. Now, knowing that these lines are parallel, my angle of depression over here is going to be an alternate angle to angle L over there, which is also going to be 10 degrees. So my angle L is 10 degrees, and the reason we know that is because we have alternate angles between the parallel lines. Okay. All right, so just a point on angles of elevation and depression, that they always are between horizontal lines, which are parallel. Okay. Now that we know that this is 10 degrees over here. Now they're asking us to calculate the length of KT. So let's see over there. That's the length of KT. So from what I can see over here, guys, I've really got 2 triangles that I could actually look at over here. I've got my triangle, in fact, no, I've got 3 triangles I could look at over here. I've got the big triangle, which is triangle TBL, okay? I've got this right angle triangle of TBK, and then I've got triangle TKL, all right? So we've got to decide which triangle is it that we need to actually work in over here to find the length of KT. Okay, so first things first, my big triangle, KT is not a side of that big triangle, so it's not going to work over there. It's either part of the right angle triangle or it's part of your other triangle, this obtuse angle triangle. And if we have a look here, the right angle triangle is the one that we have the most information in. I know the length of 25. I know that that's 17. And the fact that I've got a 90-degree angle would imply, guys, that we can just use normal trig ratios. Okay. So I'm going to once again let you go and try that during our break, okay? And just go and have a look at it, see if you can find me the length of KT, and we'll do it when we come back.
Okay guys, I hope you are enjoying this revision session. If you are struggling and need help, remember to post on the Facebook page, facebook.com/learnextra. Now it's time for a break, so don't go away. We'll be right back. Welcome back, guys. I hope you are getting into the idea of revision. Please let us know how you are doing. I'd love to chat to you on Facebook and on Twitter. Enough of the chat. Let's get back to revision.
Guys, okay, so I know you all went there, you worked it out, and you've got 26.1 as the distance from K to T. Okay, so it's the process you need to go through. You need to look at the question. You need to assess, what do you have? What are you looking for? Which triangle has got more information in it? Because that's going to guide you as to which triangle you need to actually be working in. Okay. So we now know that this length is 26.1, and the next question is asking us to now determine the length between the two cars, which is K and L. Okay, so that's what they're wanting us to do. So let's look. So obviously KL, guys, I'm sure you agree, is going to be a side of the triangle KLT. So it's this thin, obtuse triangle on the side over there. Now, it's a bit thin on information as well. It doesn't really have too much for us over here. And I know that this is 10. I now know that this is 26.1, but that's it. That's all I know, okay? So here is where you also have to start finding stuff for yourself. And this is a really important part of trig triangles. You need to find missing angles. For instance, if K1 is adjacent to angle K2, then together they add up to 180 degrees, okay? So 180 degrees would be because they're angles on a straight line. And if I take away your 17, we're getting 163. So this angle over here is 163 degrees, which is going to allow me to find one more angle, because if this is 163 and that's 10, the angles inside a triangle add up to 180, which is going to allow you to find this angle up here, angle T2. So take your full 180 degrees, take away the 163 that you've just found, and take away angle 10 that we've just found, and it leaves us with 7. So we need to just fill this all in. So we need to state that angle T2 is equal to 7 degrees. Why? Because it's the interior angles of a triangle. Okay. So we now know that that's 7 degrees. Now that's really helpful to us, because now what do I need to look for? Always start by looking for a pair. Do I have a pair where I know the angle and I know the opposite side? And if we look carefully, I know this angle over here is 10, and I know that this side over here is 26.1. That forms a pair, okay? And that being said, I now know, whoopsie, I know that that's 7, and I want to find this length over here, which is KL. So can you guys see that I'm using the pair, which means I'm going to be using the sine rule to find my distance from K to L. So I'm therefore going to say my length from K to L over sine of the angle opposite that, which was 7 degrees, is equal to the length which I've just found earlier, which was 26.1 over sine of the angle opposite that, which is 10 degrees. So therefore, your length from K to L is going to be equal to 26.1 multiplied by sine of 7 degrees over sine of 10. Okay, so let's clear our calculators and let's put that in. I've got 26.1 multiplied by sine of 7 degrees, and it's over sine of 10 degrees, and we're getting 18.3 as our answer. So my distance from K to L is 18.3 meters as the distance between the two cars. Let's take a careful read through the first question and let's see what we're going to do with it. All right. We've got point A, B, and C, which are 3 points on the same horizontal plane, and AB is 53 meters in length. So let's quickly look at that. A, B, and C. So point A, B, and C are 3 points on the same horizontal plane. That is telling us that that is actually a flat surface, okay? That those 3 points are all just the same points on a flat surface, okay? And then they've told me that I have the length of AB, which is 53 centimeters. Okay, so that's given to us over there. Right, what else have they told me? Oh, sorry, it's meters. CD is a vertical tower, and the angle of elevation of D from A is 65 degrees. So the angle of elevation of D from A. Now remember, this is a flat line. That's a flat surface over there. So the angle from the flat surface looking up to angle D is 65 degrees. Okay, so that's your angle of elevation. From the flat horizontal viewpoint, we're looking up to the point at which they're specifying over there. Okay, and anything else have they told us? Let's see. And then we've got angle DAB, which is 78, and DBA, which is 56, which has actually been filled in on the diagram for us. Right, okay, so step number 1, when you are doing a question like this, you are going to read it very carefully, okay? Don't take for granted anything that's been told in your write-up. You need to read it all carefully and make sure that you just put everything in place, that you know what's going on with your question. Then we go on to read what they're actually asking of us. Determine the size of ADB. Where's ADB? ADB is looking for that whole angle over there. Okay, so before we do anything, before we dive into it, let's take a very careful look. Let's look through all the information that we've got. Let's see if we can determine without too much working out what is the size of angle ADB. Well, let's consider the triangle ADB, the big triangle at the front surface of that three-dimensional triangle over here. We know that that whole angle is 78 degrees, and we know that this whole angle is 56 degrees. So wouldn't angle D then be the third angle in that triangle? Okay, yes it would. So therefore what we're going to say is angle ADB is equal to 180 minus the two angles that we have, which are 78 and 56. Okay, and let's work that out quickly. Right, so we've got 180 minus my 78 plus my 56, and that gets us to 46. So there we go. That's the size of that angle over there, 46 degrees. Okay, right, so that was an easy one. Please don't forget that we do require reasons, okay? So the reason that the reason why we gave that is because it was the interior angles of a triangle. All right, the interior angles of a triangle always add up to 180 degrees. Right, now that we know that that's 46, let's see what the next thing is that they are asking of us. Okay, I'm just going to fill in again that we know that that's 46 because I'm sure it's going to come in handy. Right, now they want from us the length from A to D. So let's highlight it quickly so we know what we're looking for. So that's what we're trying to find over there. Okay, so now we've got to go about looking for the length of AD, and the best suggestion would be let's start filling in what we know, okay? Let's start, sorry, that was 53 meters. So this over here is 53 meters, okay. Right, guys, so I've got the big triangle ADB that I had, which they've kind of directed my attention to by actually asking you to find the angle over here already. So we're kind of focusing on that first triangle as it stands at the moment. And because of that, I can see that I've got a pair of an angle and a side, and they're opposite each other, okay? So that's the known pair that you're looking for, and that's what's going to help you find the length from A to D, because I know that this whole angle over here is 56, which means that there's the other pair that we're looking for, okay? So, therefore, what are we going to say? I'm going to take the length of 53, and I'm going to put it over sine of the angle opposite that, which is 46 degrees, okay? And then I say my length from A to D, which is what I'd need to find, over sine of the angle opposite that, which is 56 degrees, okay? With that then said, I'm going to say 53 multiplied by sine 56 over sine of 46, and that's equal to AD. Right, so what we used was the sine rule. How did I know to use the sine rule? Because I had a pair, an opposite pair of a known angle and a known side. Okay. Right, guys, and then we're going to take out our calculators again, and we're going to work this out. So we've got 53 multiplied by sine of 56 over sine of 46, and we get 61.08. So 61.08 meters is the length from A to D. 61.08. Okay, so that's what we've got so far. Hope you guys understanding that. Okay, let's have a look at the next question. Now that we know, okay, let's just quickly go back. So we knew that that was 46 and 61.08. Okay. Now what they're asking us for is the length of the tower, or the height of the tower CD. So now we're looking for that over there. Okay, so we've now had to find the length from A to D, which essentially should be drawing our attention now into that triangle over there. All right? And let's assess the information that we have in that triangle. I know that this is 90 degrees over there. So that's a known angle of 90 degrees. And I now know the length opposite it, because that's what they asked me to do in the previous question. Okay? So once again, can we all see that I've got that pair of an angle and a side? So in that case, because I know that this is 65, I'm once again going to be able to use that sine rule to find that vertical length from C to D. So therefore, we're going to say 61.08 over sine of 90. And if you all know your special angles, we'll know that sine of 90 is actually equal to 1. Okay. And it's equal to the length we're looking for, which is CD, over sine of the angle opposite CD, which is 65 degrees. Okay, so therefore I'm going to take 61.08 multiplied by sine of 65. And guys, I'm not going to put it over sine of 90 because I know that sine of 90 is actually equal to 1. So it's not necessary to put it over 1. And then we can type that into the calculator. Right. Okay. So we've got 61.08 multiplied by sine of 65 degrees. And 55.3, let's round it up to 36. 55.36 is the length from C to D. Okay, right, so there we go. That was all the sine rule. There was no need for us to use the cos rule for that question over there. We're going to move on to the next question. Right, circles. Okay, so we said that this has its own formula, all right? Remember, if we've got a circle where the center is off the origin, you've got to use your formula of your x minus a squared plus y minus b squared, and that equals your r squared. Okay, so they're asking us first of all over here, they've told us that I've got a straight line that's represented by the equation 3x plus 4y equals negative 7. I've got a point A over here, I've got a point B over here, all right? They're wanting us to determine the equation of the tangent to the circle at B. So there's my tangent, and it's touching your circle at point B, all right? As soon as we're working with tangents, a really important bit of theory that we always have to just watch out for and see if we need to apply it is that a radius and a tangent are always perpendicular, all right? So therefore, if I've got a radius, the radius and the tangent are going to meet each other at a 90-degree angle, okay? So this is now where this is going to come in handy, because this line, my line passing through point C and point B, is the line of 3x plus 4y equals negative 7. So 3x plus 4y equals negative 7. Now the problem with the equation as it stands is that I need to get it into standard form. I need to get y as the subject of the equation. So I'm going to say 4y is equal to negative 3x minus 7, and y is going to be negative 3 over 4x minus 7 over 4. Okay, so basically what that's telling me then is the gradient of my radius, okay, is negative 3 over 4, which means that the gradient of your tangent would have to be positive 4 over 3. So therefore the gradient of line, let's call it line, we'll call it gradient of tangent, is equal to positive 4 over 3. So therefore, we're going to take the standard equation of y is equal to 4 over 3x, but we need to know what c is. We need to know what the y-intercept of this tangent is going to be. And what we know, the only thing we can really use from here, is that your tangent is actually passing through point B, which has the coordinates of negative 1 and negative 1. And as we said earlier, if you've got a point that's sitting on a line, substitute it into the equation. So negative 1 is going to go into both the x and the y, because that's what each coordinate was. And we're going to simplify. So we have negative 4 over 3 plus c. If I bring it over, we've got negative 1 plus 4 over 3 equals our c. So negative, that's going to land up being positive a third equals c. So the equation of your tangent is y is equal to 4 over 3x plus a third. Okay. Right, so just remember that, guys. A radius and a tangent are perpendicular, and that is often the key thing to remember in terms of calculating the gradient of a tangent. So always watch out for that. The next question is actually not too difficult as long as you're actually paying attention to what information you've got, because you could make it quite difficult for yourself if you're not actually thinking about it over here. What they're wanting us to do is to determine the equation of the circle in the form of x minus a squared plus y minus b squared equals r squared. So remember that this a and that b are the coordinates of your circle center. Okay? And we need to work with this. We need to determine what that a and that b are in order to get our equation. All right? So what we can look at over here is the fact that if we're paying attention and looking carefully, the y value at C is exactly the same as the y value at A. All right, you guys see that? So what I could actually say straight away is I could say that the B is also equal to 2. All right, easy enough. Okay, and how do we know that? Because once again, the radius is perpendicular to that tangent. The y-axis over there is actually the tangent. So because they're perpendicular, it has to be a straight line. It has to have the same y value. All right? So because I know what b is, from here it's not actually difficult to actually work out, because what we can do is that this point C is sitting on the straight line. And remember, the straight line had that equation over there. So let's first of all start by substituting a and b into my x and my y. So therefore I would have 3a plus 4b equals negative 7. And we already know what b is. So therefore I've got 3a plus 4 times 2 equals negative 7. And that gives me 8, which if I move it over, 3a is going to land up giving us negative 15. And if we divide by 3a is negative 5. Okay, so what is my equation going to be? I've got x. I'm going to fill that in. Remember, if it's positive, if it's negative 5, remember we always change the sign. So it's x plus 5 squared, y minus 2 squared, and that's got to be equal to your radius squared. Well, your radius is obviously, because it's actually touching your y-axis over there, is going to be exactly the same as your a in this case, okay? So looking at it, you can see that, in fact, your radius is going to be 5. So to finish it off, I've got squared, I've got y minus 2 squared, and that would be equal to 25, okay? All right, so before you go off on a tangent of working out, and when I say a tangent of working out, this could have been done by means of simultaneous equations, okay? Had you not actually used that point A over there, you could have gone the route of substituting A and B into your straight line equation. We could have substituted it into the standard equation where your R was actually the A squared. And you did land up with a simultaneous equation which actually simplifies to give you exactly the same A and B value, which is fine, but obviously look at mark allocations as a guide as to how much working out is obviously necessary when you're doing a question like that. But just take a minute to carefully look at what information you do have, because sometimes you tend to look over stuff which is actually crucially important. Okay. Right, last question over here now. If I know that I've got a negative 5 and I've got a 2, and they're asking me for point D, well, obviously, those are both radii, okay? So point D is going to be exactly the same distance from C as C is from B, so you're going to be using your midpoint formula here, all right? So midpoint formula, we're going to say, let's call D x and y, all right? To calculate the x coordinate, we're going to take x plus -1 divided by 2, and that's equal to the x midpoint, which is -5. Okay? So therefore, x minus 1 is equal to -10. So x is going to land up equaling -9. All right? And if we do it to the y coordinates, I'm going to say that y minus 1 over 2, that's going to be equal to now 2. And let's just simplify. Y minus 1 equals 4. So therefore, y is equal to 5. So obviously, just make sure you write there. The d is then the coordinates of -9 and 5. Okay.
Now it's time for a break. So don't go away. We'll be right back. Welcome back from the break. Please let me know how your prelims are going. Guys, the end is in sight and your school careers are almost over. Don't give up now, push through, and remember that every little bit of extra effort will pay off. We believe in all of you, and that's why we're bringing you Spring School from the 23rd till the 27th of September, each day from 9 a.m. till 6 p.m. And don't worry if you miss anything, because we'll be repeating the day's programming from 8 p.m. each evening. Get all the details at learnextra.co.za/Spring School. But for now, let's get back to today's revision.
Let's have a look at question 2. So question 2, so we're going to do the part now that Etsai was talking about earlier. We're going to try and just understand the question. Then we're going to devise our plan. Then we're going to execute our plan. And then we're going to evaluate our answer. Right. So the question says that A, which is the point x is 2, y is 3. That's over there. Is the midpoint of radius OP. All right, so this is the midpoint. What I like to do if I know it's midpoint is I put those little lines there. So that means that the distance from O to M is the same as the distance from M to P. So A, right, they also tell us that A lies on the circumference of the smaller circle. So that much we know. That pink dot over there, that indicates point A. Point A lies on the circumference of the smaller circle. Fine. And they tell us also that the smaller circle has a diameter of OA. Right. So that's the information. At least we've understood what they've given us. And now we need to have a look at the questions. The first question asks me to write down the coordinates of P. Right. Now, the first thing that I'm going to do is I'm going to say, all right, they haven't given me any indication as to what P is, so let me do this. I'm going to call P xy. And now I need to devise a plan. Let's look over here. I'm just taking out the bits that are important. We know that the point O is 0, 0. We know that the point A is x is 2 and y is 3, and we don't know what point P is. Right. So I've just, sometimes a sketch like this can be a bit overwhelming. Just draw for yourself the bits that you actually need. The other bit that I know is I know that this distance is equal to that distance. Right. So they're asking me to write down or to calculate the coordinates of P. Now guys, we're going to use the midpoint formula. It's got it written all over it. However, we're not going to use the midpoint formula straightforward. We're going to use it sort of slightly in reverse. We're going to say, okay, I've got the one endpoint. I don't have the other endpoint, but I do have the midpoint. And now I'm going to say the following. I'm going to say, all right, how would I usually have calculated the midpoint? I would have taken the one x value on the one edge plus the other x value. So let's do that. X plus the other x value, which is at the origin, so fortunately that's 0, divided by 2, and using this formula, I will get the x value at the midpoint, which happens to be 2. So you're just setting up a little equation for yourself. So basically we end up with x over 2 is equal to 2, multiplying through by 2, we get to x is 4. Pretty straightforward. And now we're going to do the same thing with the y value. And guys, it just happens that this point is 0, 0, but it doesn't matter what this point is. It doesn't need to be the origin. We'll do it in the same manner. So now I'm going to say, okay, for the y's, I'm going to say y plus 0 divided by 2 is equal to the y value at the midpoint, and the y value at the midpoint is equal to 3. So y over 2 is equal to 3. So quite clearly, y must be equal to 6. Now, another thing that's very important with circles is if the equation of a circle is given to you in non-standard form, you have to be able to complete the square on that equation in order to put it into standard form. So standard form would be x minus a squared plus y minus b squared is equal to r squared. Now, to me, this is one of the most important skills when you're working with circles, because until you can put the equation of the circle into standard form, you won't know much about the circle. You won't know where its midpoint is, and you won't know the length of the radius either. So we've got about 3 minutes until our first break. We're quickly going to have a look at this circle. So it says, a circle is represented by the equation x squared plus 2x plus y squared minus 4y minus 5 equal to 0. Now, I know that this is a circle because I've got x squared and y squared, and the coefficient of both x squared and y squared are the same. So that tells me that this is a circle. Now, the first question here actually talks about a transformation. It talks about moving the circle up and down and left and right. But I really can't be doing any of that until I've put the equation of the circle into standard form. So that is what I'm going to do now first and foremost. So here's the technique that I follow. I'm going to write x squared plus 2x, and then I'm going to leave a little space. Then I'm going to carry on with the y's, and I'm going to write y squared minus 4y. Again, I'm going to leave a little space, and I'm going to take my constant to the other side, and of course the minus 5 now becomes 5. So that would be your first step in getting your equation of your circle into standard form, is just rearrange it, the x's together, the y's together, and take the constant to the other side. Right, now I'm going to start with the x's, and I look at the coefficient of x. That is the number that stands in front of x. The coefficient of x in this case is 2. I'm now going to halve that coefficient, then I'm going to square it, and then I'm going to add it both sides. So that's half square and add both sides. So half of 2, of course, is 1, and 1 squared is still 1. So I'm adding in 1 over here. Now, to make sure that the equation remains true, I also have to add in 1 on the other side. Remember, it's an equation. Whatever you do to the one side, you must do to the other side as well. Then I'm going to move on to the coefficient of y. You don't have to worry about the signs because we're squaring anyway, so everything is going to be positive. And I'm now going to halve 4. And I'm going to say, well, half of 4 is 2, and 2 squared is, of course, 4. And I'm adding in the 4 in the space that I left earlier. And now I'm also going to add in 4 on the other side. Please don't forget to keep your equation balanced. Now, what you've managed to do here is you've managed to complete the square. So what I have over here is a perfect square trinomial. So I can factorize x plus 1, everything squared. So if I were to multiply out x plus 1, everything squared, I'd get back to x squared plus 2x plus 1 plus y minus 2. Your sign is determined by the middle term, everything squared, and that's equal to 5 plus 1 plus 4, which is 10. All right. So now I've managed to put this equation of the circle into standard form. So just quickly, before we go to a break, if I compare this to my general formula, I can now say the following. So it's x minus a squared. So remember, it's the opposite sign. So I can say that the center of the circle is at x equal to minus 1, at y equals to 2. So that ordered pair indicates the center of the circle, and that the length of the radius is the square root of 10, because of course that's r squared.
Okay, let's have a look at an example which hopefully is going to include a little bit of compound formulas. Okay, once again, let's look at our diagram. They've given us a diagram that they've told us that TP is a vertical line. They've told us that PQR is in the same horizontal plane. And they've given us that that's angle Y. I've got a length of A. I've got an angle of X. And I've got an angle of 150. What they're wanting me to do is to prove that. They're wanting me to prove that my length from T to P is equal to A tan X multiplied by cos Y plus the root 3 sine Y. Okay, so let's go through our steps. Step number 1, you've read your question carefully. You've taken note of everything that they've told you. Step number 2, fill in any missing angles. Okay, so for example, if that's 150 and that's Y, this angle over here is going to be 180 minus my 150 plus my Y, because it's interior angles of a triangle, which means that angle R is going to be equal to 180 minus 150, which is actually 30, minus Y. And that's your interior angles of triangle. Okay, so that's what I know this is, and it's going to help me in a minute. You'll see in a second. Okay, so therefore, having filled in that missing angle over there, can we now, step number 3, spot any pairs? Well, let's see. I have now worked out that, well, I've got a 150 and I've got a side which is A. So that's great. I've got a known angle and its opposite side. And I'm going to use that to help me find the length from P to Q. Okay, PQ is the linking side between the two triangles. So that linking side is going to help you move into the top triangle, which is ultimately going to help you find your TP. Okay. All right, so let's go ahead and find that. We're going to do our sine rule. And let's work it out. So we're going to say my length of PQ over sine of 30 minus Y is equal to my length of A, that little a, over sine of 150. Okay, and let's simplify that. That means that I would have PQ, which is equal to A times by sine of 30 minus Y, and that's over sine of 150. Now, if we're familiar enough with trigonometry, we should always remember that your angle should never be bigger than 90, okay? So the second you do have it bigger than 90, we should immediately be applying your reduction formula. So 180 minus 30 is 150. So that means that PQ is going to be equal to A sine 30 minus Y over, and 180 minus the second quadrant where sine is positive, so it's sine 30. Okay, right, so as it stands, that's what we've got, all right, and that's the length from P to Q, all right. Now what we're going to do first of all, before we do anything more, is simplify this, okay. Do we spot that this over here is now a compound angle? Let's take out the D. It's not a double angle, it's a compound angle. Okay, and because it's a compound angle, what we're going to do is expand it. Okay, so let's do that. So we've got PQ, which is equal to A. Then I'm going to expand this. The sine compound angle does the following. We're going to say sine 30 cos Y. And S for sine, S for stays the same. And then it's going to be cos 30 sine Y. Okay, so grade 12, you recognize your compound angle formula there. And what we've got for now is over sine of 30. Okay. Let's now, I hope what you've now spotted is that I've got some special angles that I can work with over here. All right? I've got a multiplied by sine of 30 is the special angle of a half multiplied by cos y. And cos 30 is root 3 over 2 multiplied by sine y. And this is all over sine of 30, which in fact is going to be also a special angle. So let's take that out. It's a special angle of sine of 30, which is a half. Okay. Right, so far I hope you guys are following what we're doing over there. So I've expanded it as a compound angle. I've substituted or replaced my special angles. Now we just have to simplify. So let's see what we've got here. PQ is now equal to, do you guys agree with me that I could actually take out a common factor here? And that common factor is going to be a half. So I've got a half A, which inside my bracket is therefore going to leave me with a cos y minus a root 3 sine y. And this is all over a half. Okay, so I hope you guys are with me and you're following. And those cancel. So the distance from P to Q that we are now sitting with is an A multiplied by, cos y minus root 3 sine y. Let's do a check for a second. Let's go and see how close we are to what they want from us. They wanted us to have a tan x. Okay, we've got the A, we wanted that. We wanted a cos y, and we wanted a root 3 sine y. So do you guys agree? In fact, all we're missing over here is that tan, okay? But we're not done, all right? PQ, remember, was just the linking side between the two triangles. What we've done over here is we found PQ. What we need to work out is TP, okay? So we've got a 90-degree triangle. So let's work with our ratios of sine, cos, or tan. From your angle of x, what we're trying to find is your opposite side. And what we now know is the adjacent side. So your opposite of your adjacent is giving us our ratio of tan from angle x, which is equal to my opposite side, which is TP, over the adjacent side, which I worked out earlier, was A multiplied by cos y minus root 3 sine y. Okay, and one last step is obviously to multiply it up on the other side. So I'm going to say tan x multiplied by, because I'm multiplying, I can rearrange the order a little bit. So I'm going to put A in the front, and I'm going to put the bracket of cos y minus root 3 sine y. And that's TP. Okay, so there was quite a lot of working out there, and I completely agree it was a lot. But what I would suggest is that, first of all, you followed your steps, okay? You read your question, you found missing angles. Once you did that, you looked for a pair to see if you could apply your sine rule, okay? Once all of that was covered, really nothing more than applying your theory, okay? So you spotted that there was a double angle, or a compound angle in this case, and that there were special angles. So there were all of these elements that were kind of brought together in one sum, but if you just take it one step at a time, grade 12s, it is manageable. Okay, so don't get overwhelmed if it's a lot of working out, just take it one step at a time.
We've come to the end of today's show. Thanks for joining us and for chatting to me during the show. Remember to visit our website, learnextra.co.za/live to get the notes and to watch the videos online. If you are stuck on any questions, make sure you post them on Helpdesk at learnextra.co.za/helpdesk. Don't forget to join us for Spring School starting on Monday the 23rd of September at 9 a.m. See you then.